Hi, we'll see the concepts of refrigeration. The two methods of artificial cooling are refrigeration and air conditioning. Refrigeration, it is a process of reducing the temperature of a system below that of the surroundings and maintains it at the lower temperature by continuously abstracting the heat from it. The temperature of the system has to be maintained at a lower temperature by constantly rejecting the heat. So for that we will use a working fluid that is called as refrigerant. Refrigerant is a working fluid which continuously extracts the heat from the space within the refrigerator, which has to be kept cool at a temperature less than the atmosphere. Classification of refrigerant is mainly classified as single component and mixed. Water and ammonia are natural single component refrigerants. Ammonia is used in vapor absorption refrigeration system. Isobutane, example for hydrocarbon refrigerant. R12 and R113 are example for chlorofluorocarbon refrigerant. R12, earlier it was used in domestic refrigerator. Hydrochlorofluorocarbon, R22 is an example for HCFC. R22 is used in air conditioners. R134A is an example for hydrofluorocarbon refrigerant. R134A is nowadays used in domestic refrigerator. Next category is mixture, zeotropic and azeotropic. A zeotropic mixture is a mixture with components that have different boiling points. Example, nitrogen, methane, ethane, propane, and isobutane constitute a zeotropic mixture. Individual substances within the mixture do not evaporate or condense at the same temperature as one substance in the case of zeotropic mixture. Azeotropic mixture are mixtures of two substances or two or more refrigerants whose vapor and liquid phases retain identical compositions over wide range of temperature. Example, R502 and R503. Commonly used refrigerants and drawbacks. So first is ammonia. Applications, cold storage and ice making plants. The drawbacks is it is toxic, flammable, irritating, and it is having a food destroying property. Carbon dioxide, it is used in dry ice making plants. Carbon dioxide is not toxic and not flammable, but its efficiency is low. It is a drawback. Sulfur dioxide, earlier it was used in domestic refrigerators. The major drawback is it will react with the water to form sulfuric acid, which will corrode the parts, metal parts. And one more drawback is it requires large capacity of compressor. Methyl chloride is used in small scale industry refrigerator. The drawback is toxic and it will burn under some conditions. Next is a freon, F12 and F22, also called as R12 and R22. F12 was earlier used in refrigerators. Now it is replaced with R134A. F22 is used in air conditioners. The major drawback is both the refrigerant will destruct the ozone layer. Next we will see the properties of good refrigerant. First one, thermodynamic properties. First property, boiling point. A good refrigerant must have low boiling temperature at atmospheric pressure. Second, freezing point. A good refrigerant must have a very low freezing point because the refrigerant should not freeze at low evaporator temperatures. Third one, evaporator and condenser pressure. In order to avoid the leakage of the atmospheric air and also to enable the detection of the leakage of the refrigerant, both evaporator and condenser pressure should be slightly above the atmospheric pressure. Fourth, latent heat of evaporation. It must be very high so that minimum amount of refrigerant will accomplish the desired result. Next, we will see the physical properties. Specific volume. The specific volume of the refrigerant must be very low. The lower specific volume of the refrigerant at the suction will reduce the size of the compressor. Second, specific heat. A good refrigerant must have low specific heat when it is in the liquid state and high specific heat when it is vaporized. The low specific heat of the refrigerant help in subcooling of the liquid, and high specific heat of the vapor helps in decreasing the superheating of the vapor. Both these properties will increase the refrigerating effect. Third one, viscosity. The viscosity of a refrigerant both in liquid and vapor state must be very low, since it improves the heat transfer and reduces the pumping pressure. Next, we will see safe working properties. Toxicity. A good refrigerant should be non-toxic because any leakage of toxic refrigerant that increases the suffocation and poisons the atmosphere. A good refrigerant should be non-flammable. Third, a good refrigerant should be non-corrosive. It should not corrode the metal parts of the refrigerator. Fourth one, chemical stability. That means a refrigerant should not decompose under operating conditions. Other properties. COP. The coefficient of performance of a refrigerant must be high so that the energy spent in refrigeration will be less. Second, odor. A good refrigerant must be odorless, otherwise some foodstuff will lose their taste. Leakage test. The refrigerant must be such that any leakage can be detected by the simple tests. Fourth, action with the lubricating oil. The refrigerant must not react with the lubricating oil used in lubricating parts of the compressor. Thank you for watching.